So let me very quickly give you a rapid survey of what radioactivity is all about. There are three major ways that radioactivity comes about. Alpha particles, which are 2 neutrons and 2 protons, and they basically can't even penetrate skin. So if you have intact skin, you're okay. Beta particles, on the other hand, those are electrons, and they can travel several meters, and the way they enter the body is primarily through inhalation, ingestion, or being absorbed through the skin. And then you got photons, or gamma rays. Gamma rays basically can travel hundreds of meters. And not only that, they can penetrate clothing and skin. And basically, for gamma rays, to protect yourself, you basically need lead shielding. So, there are 4 radioisotopes that we know are dangerous to man. I-131, cesium-137, strontium-90, and plutonium-239. Iodine is primarily a beta and gamma emitter, so photons and electrons primarily, and it can cause thyroid cancer. And if you all remember, 1 year ago, in March, there was this big rush. Everyone was buying up potassium iodide with the idea that they would protect themselves from thyroid cancer. What's interesting about that, I-131 only has a half-life of about 7 or 8 days. And it's long gone after that. Or it decays very rapidly after that. So it's only dangerous for a very short time frame. And the reality is, even if you were to develop thyroid cancer, you know how we treat it? With I-131. We radioablate the thyroid gland if you got cancer. So there was a big scare. Now understand though, iodine-131, you're going to find that, you're going to find iodine in kelp. So nori basically can be a problem. Cesium-137, this is really the bad actor one of the bad actors in my mind, because it has both beta and gamma rays, so it basically can penetrate everything, and cesium behaves like potassium. And potassium basically is picked up by plants, and it's concentrated in fruits and vegetables. Just think about it, when people have hypertension, we have on medications, we tell them, drink orange juice or eat fruits and what have you, bananas and what have you. That's to get enough potassium. Now guess what? Cesium-137 goes everywhere that potassium does. And last year, I don't know if you recall, but the beef in Japan was contaminated. The famous Kobe beef was contaminated. Why? Because the cesium-137 had been picked up by the grass, cattle grazed on that grass, and it wound up in their bodies. And therefore the meat became contaminated. Strontium-90, this behaves like calcium does. So it goes to bone. And so therefore, it can cause leukemia. And right now in Japan, it's also causing a different type of cancer called multiple myeloma, which is a type of bone cancer. And then we got plutonium. Plutonium is not so much a problem, let's say, in most situations, because it just can't penetrate anything. However, if you eat it, if you eat the dust particles containing plutonium, then you can wind up with gastric cancer. And parenthetically, the cesium-137, that's probably responsible for the gastric cancer epidemic that we had in Japan in the 60s and 70s, and also in Korea, because the fallout of Hiroshima and Nagasaki fell right onto Korea as well. So there are many deaths of individuals from gastric or stomach cancer 20 to 30 years after the bombing of Hiroshima and Nagasaki. And right now, as we speak, in Scandinavia, where the Chernobyl accident had its fallout, there are reported a fair number of cases of gastric cancer now. Okay? Plutonium, even though it doesn't penetrate skin or what have you, the problem with it is that it's got a half-life in tens of thousands of years. So it is going to be around forever. Okay, once again, real quick word that we measure the radioactive dose that people get in what we call millisieverts, and the background is somewhere in the range of 2 to 3 millisieverts over a year's time, and the Nuclear Regulatory Commission basically has suggested that maybe 20 millisieverts per year is excessive, and that's where they set their limit in terms of exposure. The standard chest X-ray is 100th of a millisievert. CT scan is 25 millisieverts, so that's getting up there. I don't know how many of you know, but Cedars-Sinai Hospital, they had a problem with the way they were adjusting the dosing, and they exposed a number of individuals with doses in the range of 250 millisieverts, which is actually the US limit for emergency personnel. They should never go close to radiation if they get that much. So what we're saying, therefore, is that those individuals who got CT scans at Cedars-Sinai about 1.5 years ago, basically, they will probably develop a cancer of one type or another. And then we've got radiation sickness, and that's at 1 sievert or 1,000 millisieverts, and 6 sieverts is uniformly fatal. Okay, and then I already mentioned the issue about the potassium iodide. And then I'm sure most of you are very familiar with the story of Sadako Sasaki. Sadako basically was 2 years of age when the bomb was dropped over Hiroshima, and many of her friends perished, but she survived. And not only did she survive, she grew up to be a very healthy, athletic young girl. In fact, she was the fastest girl in the school. She was so athletic, she was so fast, and she and her friend, Shizuko Hamamoto, basically tried out for the track team, and they won. They made it. They were on the track team. The day after she tried out for the track team, she passed out. Next thing she knew, she was in a hospital. And she had Genbakubyo, atomic bomb disease, otherwise known as leukemia. And very early in her hospital stay, Shizuko visited her, Sadako, and gave her a golden piece of origami paper. And Sadako said, "What's this all about?" She said, "Oh, don't you know, if you can fold 1,000 paper cranes, you can get any wish that you want." And so Shizuko asked Sadako, "So what would be your wish?" He said, "Silly, of course, to get over this stupid disease that I've got and help you and the team win ribbons for a track team." So dutifully, every day, friends or family would bring pieces of origami. She would fold it and make paper cranes. And in fact, the Japanese-American National Museum relatively recently in Los Angeles had an origami exhibit. In that origami exhibit was this little tiny paper crane that Sadako had folded from a candy wrapper. So little piece of candy wrapper that she managed to, and I don't know how she did it, it's so tiny, she folded it to make a paper crane, and that was one of 644 paper cranes that she did fold before she died. So at 644, she died of her leukemia, and so the family and the community actually got together, and at her memorial service, they made up the difference, and there were 1,000 paper cranes. And a year after that, the city of Hiroshima created a memorial in her honor, the Sadako Memorial, in the Peace Park in Hiroshima. And on the memorial, the inscription reads, well, of course in Japanese, but "Hear our cry, hear our prayer, peace on earth." And to this day, actually, schools in Japan, a different school each day, colleges, elementary schools and what have you, it's their day to bring their 1,000 paper cranes to the Sadako Memorial. And so that tradition is still being carried on. Yeah, parenthetically, the Hiroshima Peace Park, and Nagasaki too for that matter, both of them in the museum